Good morning, everybody, and welcome to, as I say, day 3/5 of PASS Summit 2019. I hope you're enjoying your final day at the summit, and hopefully today we are going to have a little bit of fun whilst getting some educational learning about big data clusters and seeing as much about what it can do as opposed to just going through architecture and stuff like that. So what I wanted to do is we're going to go through some demonstrations of what this technology that we have released in SQL 2019 can deliver for you, and what you can do with it, and how you can use it, and how you can integrate it into your environment and into your working practices. So before we start, please make sure that you have all your cell phones set to silent or off, because you'll need those for voting purposes. But do please keep them quiet for the benefit of the recording. I do want to just call out that PASS as an organization, it offers an enormous number of resources that covers the entire kind of Microsoft data platform. I do encourage you to make sure that this isn't your last engagement with PASS for the year. Go to your local SQL Saturdays, travel to SQL Saturdays, go engage with your local user groups, and have a great time with your peers in the community. It is, I can honestly say, one of the best accelerators for your professional development that you can possibly do. And I can talk about that from personal experience as someone who has both organized SQL Bits in the UK for many years and also sat on the board of directors at PASS, as well as being recognized by Microsoft as a data platform MVP right up until the point that I actually chose to join Microsoft. So my name's JRJ. I'm a principal product manager at Microsoft, and I focus on Azure Arc these days, but I've also been working very closely with the engineering team on SQL 2019, data virtualization, big data clusters, and before then, Azure SQL Data Warehouse, Gen 1 and Gen 2. So, what is our agenda for today? Well, our agenda today is to really keep at a very high level what BDC is, what you can do with it, and how do you get to the next level on BDC, right? So that's kind of what we want to get to out of this session. Nice, light, demo-heavy session. So let's just start with a little conceptual overview about what BDC is, and we're going to meet these two cheeky chaps later in the session, because one of them is looking a lot more confused than the other one. And so hopefully by the end of it, we're going to be in a much better state. So here we go. What is the main point of big data clusters? It is a unifying data platform that you are able to control, build, and manage in your own environment. And it is designed around the concept and the construct of analytics. I like to think of it as three big buckets, right? I think of it as SQL Server 2019 and all the benefits that you get out of that. You get Apache Spark, which is a general-purpose compute paradigm for running operations and workloads in conjunction with SQL. And why is that important? Well, think about databases, right? How many times have you guys hit a cursor and sort of, like in the database, you'd be going, oh, can't believe someone's doing kind of row-by-row procedural programming in the database. Well, Spark loves that, right? Spark is a procedural programming paradigm, right? It gives you the ability to operate in a procedural way over data as a general-purpose compute, but it also gives you ability to do other general-purpose activities like machine learning and ML and AI-type activities. But what do both of these things need? They need low-cost storage. They need that to be able to share the data as a common place to house that data. So we also ship Hdfs in that box to make sure that what you have when you're looking and thinking about all of these things is a single uniform hub for all of the analytical purposes that you want. Now, everyone thinks about big data clusters and they go, oh, I don't have enough data. Big data is not just about a volume-based paradigm. It can be about how you have diverse data and you want to be able to work with different types of data and how you're going to curate data and how you're going to work with it, whether it's in a tabular format and been squared off, right, as a table, or if it's in some irregular format. How are you going to work with that data? So the whole point of big data clusters and the surrounding technology that we're providing is just the ability to go and work across any type of data, right? And that you have that power in your environment. Now, in order for us to be able to deliver these services, we use Kubernetes as a substrate. And we use that because it is a huge shift in our industry for things like provisioning and orchestration and an abstraction over storage. I personally believe that we're going to go through in the next 5 years or so this move from seeing the physical to virtual migrations that we saw kind of in that kind of 2010, 2012 type era, and everyone was going what we used to call P2V migrations, right? We're now going to see going from V to C, right? From virtual machines into containers, because containers are ultra-lightweight ways of operating over that data, or at least they can be, and it gives you a completely consistent experience over those data sets. Kubernetes is a great orchestrator for containers and is a very important statement. And I want the team here to understand that actually working with Kubernetes is an important part of your development life cycle as professionals, as data professionals. And I would strongly encourage you to reach out to members in the community that are already advocating that. So we have Anthony here in the front row over here, and Ben as MVPs that are working in that space and actually showing people and educating them on this technology. And I would encourage you all to leverage the resources that they're illustrating in this world, right? Because actually it is a big concept and it's a lot to take in. And so having people actually helping you in that space, and what the whole point of community is about learning from one another. So I'd encourage you to make use of those resources that they're providing and then go and create some of your own once you've actually gained some experience. Now, in our world, we have 3 tools to rule them all, right? We don't, unfortunately, subscribe to the Lord of the Rings, but we do have 3, right? So what we use kubectl for Kubernetes management. We use Azure Data Studio for notebooks, IP accelerators like wizards, and querying tools. And we have AZ Data. AZ Data is our CLI. And we use that as an abstraction over kubectl to give you even easier ease of use, easier provisioning, and ease of management. Okay? So 3 tools, command line, cross-platform experience with Azure Data Studio, and kubectl. Now, that is not just all that's in big data clusters, but it gives you a really good idea. One of the key things that I like to think about and talk about is the fact that actually the other thing that we put in the box is logging and telemetry straight out of the box. So as soon as we start up a big data cluster, we also provision Elasticsearch with Kibana as an interface, and this is a Kibana interface. And all of the SQL logs that are being generated by the SQL containers that we use are all aggregated right up into that node, right, into the Elasticsearch. So you immediately have something that's even better than you have in SQL Server. You already have an automated logging framework for all of the logs. So you will see in a second, we're going to get into doing some kind of like using of that Elasticsearch Kibana interface to be able to actually go and query those error logs for SQL across an entire distributed architecture, right? And then the other thing that we do, again, straight out of the box, leveraging the open source and embracing that open source technology, is that we use Grafana to basically, as a visualization tool over things like InfluxDB. so that you can actually capture the data in InfluxDB, and we actually exhaust telemetry into there for both the nodes and the pods and those SQL instances, so that you can then go straight into something like Grafana and visualize it and get a sense of what's going on in your environment. And it's all there for you straight out of the gate. Now, in terms of what is BDC, that is literally all I'm going to talk about. Right? There have been some great sessions this week. If you haven't been able to go to those, I would strongly recommend getting the DVD or going to one of Ben's other sessions at one of the other many community events where he's speaking, and where he talks about the whole infrastructure and the architecture of big data clusters and does a fantastic job at that. So I would encourage you to do that. And there are some other resources at the end of this deck that I'm going to send you to for the next level up. So what are we going to do now is we're going to talk about what you can do with BDC. Okay? And this is where we come back to our two cheeky chappies, Mr. Confused and the educated one, desperately trying to help him, right? And what we realize here is that actually what we need to do is to provide some clarity. And for that, we need Wendy's, okay? So, as I said at the beginning of this slide, at the beginning of the presentation, this is an illustration of big data clusters using a dozen Wendy pastrix. And the reason for that is, here is Wendy. And you look at the guy sat next to Wendy. He is very, very happy about the clarity in which he is providing to him about Wendy Pastrick and her amazing demo. So what we're seeing here, and it's just somewhat coincidental, that every single one of the demo slides has Wendy's face on it, and it occurred to me that this would be a fun game to play. So what we're going to do now is go through, I'm going to show you the 12 demos in the slides, and then we're going to flip over to the demo environment. We're going to just talk through them. Every single one of these demos, we'll talk about them. Notice the hashtag, BDCWendy01, BDCWendy02, etc. I want you to use your Twitter handles, and you can vote for your favorite BDC Wendy moment of clarity. And hopefully, we'll be able to then actually parse that data and go and get a winner. And Ben over here has a prize to give to you, to the winner, which is obviously a Wendy's gift card. So let's go through what the demos are, then we can put the slides away and move on with the rest of the session. So BDC Wendy 1, we're going to show you how data virtualization works and how you can use this new feature from SQL 2019 to virtualize data across your organization. Number 2, we're going to upload data into the storage pool, that Hdfs layer. We call that a storage pool because it has a bit more in there than just Hdfs. So we're going to upload data into there, and I'll show you a variety of techniques for doing that. The third one is we're going to connect a Kafka stream using a tool, a product from an ISV called StreamSets that connects directly into BDC. So you can take a Kafka stream and plumb that into your SQL environment, into your BDC, and stream Twitter feed data into there. No surprising where we're going to get the answer to our who wins question. We're then going to use Prose. Prose is some MCR, Microsoft research technology for doing some data cleansing. And then we're going to query data in the storage pool and do some additional ad hoc query analysis over that data. And then we're going to extend the storage pool with a neat little bit of tech called Hdfs Tiering. And, well, hey, Wendy has arrived just in time for Wendy 6. So future past President Wendy is at the back, and welcome. So time to perfection. Dramatic entrance, Wendy. Thank you very much. So we're going to extend the storage pool with Hdfs Tiering. Then we're going to load the data pool with SQL. We're then going to load the data pool and query it using Spark, and we're going to show you different reasons for doing that. Then we're going to transform the data and persist it using Spark, do some data visualization using Sundance, create ourselves some custom monitoring in Grafana and Kibana in particular, Finally, we're going to deploy an ML application into the BDC, and then we will come back for the next level stuff, right? So that's what we're going to try and do in the remainder of the session. Okay, sound good? So let's move that down. Come here. Now you can see here on my screen, this is Azure Data Studio. This is our Data Studio environment. And you can see I've already connected here to a big data cluster. It is just a straight regular SQL connection, but it gives me more than I would just normally have, right? So for a start, I would have here, you can see there's Hdfs, for example. Now, I can also use ADS to even deploy big data clusters by just coming here and clicking deploy. And you can see here, I don't have the Docker thing here, but if I wanted to, I could come over here to the SQL Big Data Cluster piece, click on that, and it'll actually trigger me through a wizard experience and generate me a notebook that has everything I need in order to be able to provision that in AKS, right? For example, I just pick the instance, and I say I want a new AKS cluster or an existing kubeADM cluster. And so I can get going very quickly. I don't need to do that. So if I just click down and cancel that for a second, in the time-honored tradition of here's something I prepared earlier, I have actually deployed my big data cluster, because that will take 20, 30 minutes or so to go. But just so you can see what the wizard experience looks like, the notebook, I did keep the notebook I used. You can, and I will try and do it where I can. It gets a bit exciting when I do. I will try, though. So just so you can see, it just goes, a bit fast. So all it says is it's just going to go through a setup. It does all of this variable configuration. You can see here's my configuration. I'm deploying it onto AKS. I'm not doing anything particularly fancy. It goes and checks all the dependencies, make sure I have my 3 hero tools installed. We set a password, obviously. I pick out my Azure subscription. I deploy it into a resource group, create the AKS cluster. You can see that is literally 1 line of code. And then everything I just talked about is deployed with a single line of code. We've just got that summarized here, but see what I mean? It kind of goes everywhere. Okay, and you can see I'm just running AD data BDC create. I pass in a YAML file, and boom, it's off, right? And it will go and do everything for you. All of this is pre-generated for you. All you need to do is click Run Cells at the top, and then let the magic happen. And you can see that we then put the output directly back into the notebook, and here you can see I've already deployed it. It's all very nice, right? And so now we have an instance called JRJ BDC, and that's what we're going to use for the rest of the demo. You'll also see all of the endpoints, all of those things that I was just talking about, they're all here. Here are all the endpoints. They're all linked for you, and then you get to be able to just click here, and it will actually even put it into Azure Data Studio in the nav so you can use it, which is exactly how I got it into the nav there. I can also, just so we're clear, come here on the controller, click here, right-click Manage, and I get back exactly that experience that we were just looking at there once I've worked out how to do this whole zooming around the page thing. I'm going to just ding it down for a second. So you can see there it is. All I did was click on the Manage screen, and I got all of those endpoints back, and so I know how to work around it. Okay? So that does not count as one of our Wendy's, but it is pretty cool, so I wanted to show you. So the first thing we're going to do is BDC Wendy 01, which is data virtualization. And one of the most popular concepts or conversations that we've had with customers is around doing this, using this tech, has been around data virtualization across all of SQL 2019. This has been a huge kind of thing, right? And one of the things that people have been most interested about is around Oracle. So I will zoom it back in as we go. I just want to make sure we're connected to the right instance. Let's see if I can get that to go just a little smaller. No. OK. It's being mean. So what we have to do, we've got our instance to 2019, past 2019. We create the master key in the instance. Now we create a credential to be able to go and access that instance. We're going to connect over to an Oracle XZ instance. And we're going to use the TPCX Big Bench dataset that I've loaded up into there. And I'm not very imaginative when it comes up to names. So I'm going to create that existed object there. We're going to create the external data source. And I'm going to create a schema. It's just, I've already created it, so it's fine. So now I'm going to create an external table. The external table is just a metadata representation of the data. The data will always physically reside in Oracle, but we're going to access it. We're going to access it using a three-part name. We're going to access the web clickstreams table over TPCX in the service name of XZ. So we just go and create that. And now if I want to query that data, we're now going to push that count and down over onto Oracle and run it. And you can see, there we go, we've got our data back. Now if I go and create another external table, this time I'm going to create the item table, exactly the same, nothing very fancy there. And you can see that here I have the same thing, and I can see the metadata of that table in sys.external tables. I could even edit that and show you that this table, as far as SQL is concerned, is just a table, because when I do that and run it, there you go, it's just a table. So from the optimizer point of view, we're making some very opinionated decisions. We're using the SQL cost-based optimizer to be able to operate over that database, and we use things like statistics to be able to do that. So you can create your own statistics on that external table and then use those to provide even more information into the optimizer. So now I can have a query like this. I could run that, and away it goes. Now, I could also, for example, use other data sources and connect those and join those, because ultimately SQL Server is deciding what's going on and what goes where. And you can see that I've now run that. Here's the data, and it's back in our instance. We're going to use that query quite a lot. Now, for those of you who may have not used data virtualization in SQL 2019, you can also do some other fun stuff with this that you couldn't previously do. We actually have advanced the concept of the external table quite a lot. And one of the main things that we changed is the binding. In the past, if you were using 2016, everything was column ordinal-based binding. Now that binding is by the column name. Now, because of that, we actually need to make sure that we are referencing exactly the right column. And so if there are restrictions, like in Oracle, that you have to have like uppercase names and stuff like that, and there are other things about the data, right, like collations, we actually require you to provide that information. So if I come in here, you can see that when I was looking at this Oracle table, yeah, I've got here on this customer instance, right, I can create that, no problem. Now I'll create it, drop it and create it. That's no problem, and then I could go ahead and query that. Okay? Fine, no problem. But I can also do some other stuff, right? So for example, I could just say, actually, I'm only interested in all of this data, and actually, I want to represent it like that. Okay? That also works, because obviously, that's all we're interested in, right? So that's what the name binding requires. Now, you can also see that here, I've got that collation in place because of the nature of that Oracle instance. So what happens if I get some of this wrong? So let's put this into lowercase. And I can also say, for example, whoa. All my beautiful formatting is gone. And now I get an error, okay? Because, now in the past, with Polybase, this used to be a bone of contention because it was difficult to then know what you were supposed to have said or done or what was wrong. What actually Polybase is doing now under the hood is it's actually saying, actually, this piece here, can you see this? The detected external table schema is, and then it actually shows you exactly what it needs with the collations it requires. So you can then pick that up, just plop it back in, and away you go. Much, much easier, right? And then just for the benefit of it, I can just delete that one and run it, and we're back. And it will, that should now be fine, yeah. Okay, so just some data virtualization enhancements that we've made to there, so you can see that as well. So the first thing that you can do with your big data cluster is go out and connect to any of these kind of data sources like Oracle, MongoDB, Cosmos DB, other SQL services like Azure SQL Data Warehouse, and actually connect to them and virtualize that data. Yeah.
Since it can detect the schema of the source,
Yeah. So, great question. There's a couple of things that we do offer in that space. So, if I was to come up here and click Manage, see this thing up here? It says Data Virtualization. This is an extension. I can click on the external table extension. I'm going to wish I wasn't in here. I could actually come over here, click on Oracle, pick my target database, click Next. I can set a master key password, and then I will actually go through and it'll actually detect all of the schema, and then it will generate all of the code for you. So you can just do all of that. I just time of all my Wendy's, I'm just not going to do it now. Okay? But you can do that. Okay? So that's that one. So great question. Why is this better than a link server? The reason why I would say from a link server point of view, link servers are outside the scope of a database. That means they're not part of the availability group, for example. So you can't basically use it in that way. Link server requests are single-threaded. Here we can actually scale out the read because one of the things about the distributed big data cluster is it is actually a distributed environment. So I can actually go and connect to a bunch of, I can actually scale out the read. And so especially if you have something like a partitioned database table, I can actually parallelize all the access and actually accelerate the query, something I can't do with link servers today. So there's just a couple of reasons. Okay? Yeah? Yeah. That determines it determines what shape of the query we do and therefore what we push down. Once you know what you can push down, and that you use sysdm external work, or sysdm external work, you can go in and actually see exactly what we push down, and then you can optimize even on the back-end source. Okay? So, that's one. Okay, second one is now we're moving into uploading data to the storage pool. So BDC Wendy 2. So moving in, what we're going to do here is just go back into Azure Data Studio, for example, here. No, that's not Azure Data Studio. This is. And you can see here's my storage pool is HDFS. And have I got data? Right, I'll just quickly delete this one. And it's going to want me. Yep. And now all I need to do if I wanted to do that is I can just come up here, click Upload Files. And I've now just uploaded that data into HDFS, no problem. Now, if I wanted to do something else, like, for example, using other tools or technology, for example, I want to use curl and curl the data in, I can do that, right? So in this case here, I'm just creating this directory. So we're just going to initialize this script. Okay, and you can see our endpoint, right? And all I've done there is used AZ data BDC endpoint list to show me my endpoints and give me a specific one, which is web HDFS. And I've converted that to, from JSON into a table object that I can then parse into a variable nice and easy, right? I'm now going to go and just create a directory called parse 2019. Apologize. And always gives me a bit of a heart murmur because the upload text of curl, for some reason, is always in red. So, but you can see here, I've created that directory. Here's my true. I could then go and upload a file, like my store data, into that directory. And what I'm doing here, just so we're clear, is on that web HDFS endpoint, I'm just saying, here's the directory. There's my file. The operation is create the file. I can then list the contents of that directory. And you can see that. There he is. And then if I want to deleting there. Okay, and so I've just removed that directory. And the reason I'm doing that, just example, I'm just showing you exactly how you can manage and operate that. But that's one way of doing it via curl. You could do the same thing. We put the thing into an environment variable here. But AZ data, you can see it's a little easier for you to be able to use AZ data to be able to do exactly the same thing, right? So there, I'm just creating the instance there. I load up the same file just with a copy command. a second. Has he gone in? Yeah. And then should be able to ls on that data. You can then see my store, what the permissions and ACLs are on that, and then I can do a cascading delete. Just be careful where you run that. That's a bit of a Spider-Man message. With great power comes great responsibility. So that's my public service announcement. And you can see that I've just operated that. So I've shown you how to load data into the storage pool. You can load any data you want. You can then have that in HDFS. Everything is good. OK. Has BDC Wendy 2. Let's get rid of this. So, stream sets. Very simple scenario. I'm going to actually drop this for a second. Just it's too painful. We're just going to connect into a cloud service called StreamSets. This is a third-party application that was part of our preview, and they put a lot of energy and effort into supporting big data clusters as an early adopter. And you can see here that I have a pipeline, basically a pipeline tool, and we're going to have a couple of pipelines, right? We're going to Twitter stream data into Azure, and what you can see here is I can say what it is, and you can say I originally had this on past summit, but I'm going to be brave, and we're going to put in BDC Wendy, right? So I'm going to come up here, hit my parameters, and I'm going to put BDC Wendy. Now, I am now completely at your mercy for abject humiliation if none of you vote, right? So I'm now going to publish that pipeline, and you can see that this pipeline runs it into Kafka from that stream data, and then the second pipeline that we built with them just for this demo actually takes that data, and then from Kafka, we ingest it into the big data cluster over here on the right-hand side. So if I now come down here, we go through to what they call a topology. Now, as you know, I edited that, so I'm going to come over here, update that pipeline in the topology. So I'm basically just leveraging their versioning technology. And then what we're going to do is come back to this and start what we call start all jobs and initiate the pipeline. We're going to capture some Twitter data. Hopefully, we're going to get some BDC Wendy's, and then we're going to pick one using the mighty power of SQL. Right, so we'll come back to that at the end. OK, but hopefully that gives you a clear thing. That is our BDC demo 3, and so now we move on to pros and cleaning data. So BDC Wendy 04. Yeah. That's that would be something we're looking for feedback on the roadmap for as to whether we put it in the BDC or whether we leave it outside the BDC for people to connect in. But we are looking for feedback as to whether or not that's a popular scenario. So what I would suggest is that we have a feedback mechanism called on aka.ms whack SQL feedback. Please do that, and if you like it, vote on that topic, and I'd love to kind of get some more data points on that. Okay, but for now, we're just going to quickly flip over to opening another notebook for pros. And here's our data prep notebook. And you can see that it takes a few seconds just for the kernels to load. But now we have what we call we have our pros notebook. OK? So what we're going to do is import this data. This is a Microsoft Research product, Pros. There's a ton of documentation on it. I'm going to show you a super simple example where we're going to just read that flat file in. It's called artists. And that data set, as I can show you actually, has just some complex aspects to it, just in as much as there's a bit of garbage at the top, which is like some additional metadata in the artist file. Come on, virtual machine, don't be nasty. So it's just got some additional stuff in there that's not going to make that easy for us to just straight away read. And there is a whole bunch of capabilities in this space using Pros. But I can go back into here. I've now what Pros does is it generates code to help you actually then go ahead and do the parsing of that file. So I'm now going to pick up the code that it generated, and it's using pandas to do that, to provide me with a data frame. And then I'm going to execute that code. And now I have a data frame with that code loaded, so I can read it. And there you go. It's just eliminated all of the stuff. It detected all of the issues that were in the file. It's parsed it. I can now just read that data as though it was anything else. And I've just done a head 20, so it's just like a top 20 of the data. And it's just some artist data. Now, this also extends to things like JSON. And so what better way to explain the power of JSON than using a JSON document filled with Pokemon? And so in this case here, we are able to ingest a JSON of Pokemon information, which I consider to be essential for a monthly community day. And then I'm able to then execute that code. And I'm just going to flip this down. It's just not. And now I can see here I have out of a JSON doc. I've now parsed, flattened that out. I can now just see, and I can get a very quick visualization over that JSON data without having to do anything else to it. But what if I want to do something more? Well, in that case, what I need to be able to do, for example, one of the things that's essential information in Pokemon is how do you get and evolve your Pokemon? And what do you need to be able to do? Well, what we're going to do here is reread the data frame. We're then going to look at all of the ones that have a zero or a null candy count, i.e. these are the most evolved Pokemon. Where am I going to be able to find them? Right? So I can now run my DMV. I can now see the highly coveted Mew in my data. And if I just scroll over, you can see that he's not in eggs. You have to do the special research task. So off you go, everybody. Go hunt your Pokemon. And actually, one of the things that's great about Pokemon Go is all runs on Kubernetes. So what a tie-in. Right. So that is Pros. So what are we doing? You're just helping people accelerate their ability to query and understand complex data sets without actually having to do anything in terms of writing the code themselves. That's pretty sweet. And that's Pros. Moving swiftly on, we're now going to look at the storage pool. So go back in here. And some of this is suddenly going to start to feel a little familiar. Because then we come into the storage pool. And what are we doing? Well, we have a master key. Right? We're then going to create our external data source. This time, we're going to create one for the storage pool. We're then going to create a file format. Why are we creating a file format? Because we need to be able to read and understand that file format specifically. And now we need to be able to create the schema. And here we're going to create the external table and our other external table. And now we're going to run exactly the same query as we did before, but this time we're just running it against the storage pool. So that storage pool example that I showed you before, where we were running against, the Oracle instance, it's exactly the same. We're just using now the storage pool. We put it into a schema called Hdfs. We're running exactly the same query. Okay? Now, it takes a little longer because we're coming up on the storage data, and I'm running this in a dev environment, so it's not a reflective of performance. But it gives you an idea of how exactly the same thing works, and I've put the same data in exactly the same places. So you can see that it's run. It took about 30 seconds that time. But you can see that we're getting exactly the same kind of data set back, and I'm just running over exactly the same data set, right? I'm just sharing that data across those environments.
Quick question. We were able to do these things in 2016 politics. Has there been any advancement made on this side?
Yes. So one of the things that we're actually doing here is actually when we're reading that data, especially for text and Parquet, we're actually reading it directly through the SQL Server optimized. And SQL Server we actually have like a Parquet reader kind of built inside of SQL so that we can actually push down even more of the predicates into those files. So you should get a better performance experience querying data through the storage pool than you would through a remote HDFS layer. Because that requires a spin-up time on like a Cloudera instance or something like that of the MapReduce job to get the push down. So here we're able to kind of get into the data much easier, much faster. And no. Yes. So that's why you get the better perf. Okay. So that's that one. Now, let's go into the next one, which is Hdfs Tiering. Now, Hdfs Tiering, what we're doing is we're actually going to connect an Azure Blob Storage account holding that same data set and we're going to connect it and put it into our environment. So what are we doing? We run az data bdc hdfs mount delete and then mount create. Okay? You can see when I put the credentials, I actually pass in the account, the storage account, and the account key to be able to do this. And then I'm basically just going to poll for the data set, right? So I'm just going to run this now. And there we go. We've created the mount, and the mount is ready. So now I can come over here in Azure Data Studio. I go over to my mounts location, which is here. Here's TPCXBB, which is what I just mounted. All of this data is actually physically resident up in Azure. Okay? but we are showing it here, and we cache that data when we read it. So now I can come down here to, say, my warehouse table. See that warehouse CSV? I can now create an external table from that. And forgive me, I'm going to drop it down. I'm going to say, put this into my past 2019 database. OK, we're going to give it a name. Hit next. There's the data set. There's the schema. Create table. OK, job done. I have an external table. I can now query that data as though it is part of the BDC. I've now extended and enhanced my Azure Blob storage through the BDC, right? So, and so I can bring all of that data to bear as well. So now I'm just going to change that. Run the initialization, check that, good stuff. We'll create a schema called tier. We're going to create an item, external table called item. I have got my tiering example wrong. So I'll just cut that just because for interest of time. But I could basically just connect and run exactly that same query again, just using that. I just missed the file format. So that's Hdfs Tiering, and that is BDC Wendy 6.
Do we have this capability for on-premises BDC?
This is all on-premises BDC. I'm just running it in AKS just because it's easier for me to deploy it there, but that makes no difference. OK.
Question about authentication question.
Sure. No, that's not. No. So one of the most biggest parts of investment that we have in big data clusters is we have Kerberized the big data cluster. I'm just using basic auth because I didn't have time to set that up, right? You can do it. So now I'm just going to go in and look at the big data clusters data pool. And this is the 7th one, so we're going to create our external data source. We're going to create a schema for the data pool. And then we're going to create a table called click web streams and put that data into there, right? One second. Did that not go through? Oh, I know. Sorry. Thank you. The details. So that's just going to create that external data source. The external table. And now I'm going to move data from a database I have up on the SQL Server in big data clusters down into the data pool, which is at this scale-out distributed database that we have inside the big data cluster. And the reason we have it there is so that you can hold even more data and keep that isolated from the rest of your environment. So it's going to take a little while just to move the data down. And but we're using it to keep it's a fully distributed table that we're created. So we just moved over about 6 million records. We're now going to do the same for item. And then we're going to insert data into there, but we're going to move it from Hdfs. So I just have to quickly do one quick repair on the storage pool. One of the challenges of running multiple instances. Did that run? I missed one. So just add a and now it should go. There. There we go. So there we go. So just a slight hiccup on where I had this created. So now I've moved data up from the storage pool. I've put that up into the data pool. I've taken data from the master instance of that SQL server and pushed that down into the data pool. And now I can run the same query again, but now I'm going to run it completely from the data pool. And you can see that actually we'll get a better performance experience just because we're running it out of the data pool. And the reason for that is that the data pool is running in columnar format in a distributed fashion, and so you get the advances of putting the data into a proprietary format. Okay, so there we go. That's loading the data into the data pool using SQL. And that is demo 7. Demo 8, we're going to log in and run this data pool using Spark. So we're going to create this database in Spark. We're going to create the login. We're now going to move it over to pass, create the user, and grant access to that user. And then we're going to use the external data source that we have available. We see we have our data pool there. Now, this is some new syntax that's available in SQL 2019 Big Data Cluster, so I'll zoom it in for that. What we're doing is using something to actually push a query down even into the data pool. So we give you the ability to actually run federated queries down. And the syntax for that is execute at, and then you pass in the thing that you need. what we're going to do is load the data with Spark. So we actually need to create a login for Spark in that instance. So I'm just going to quickly run that. And he's in there, and there's my current beau, Mr. Pierre-Emerick Aubameyang. So on to and here's our Spark scenario. So we're now going to kind of run some basic Spark to actually bring the data in. So we're just basically going to read data from the from our HDFS layer, that TPCX Big Bench database item and web click streams. So we have to wait a little bit for the first one because we're actually initiating a Spark session. And all we're doing is saying to Spark, here's the data, this is where it is, it's got a schema, and so you can, well, it hasn't got a schema, so infer the schema and read it. So it's just read item, we're now reading the web click stream, and then we can do some basic analysis. And this is where Spark kind of comes into its own. And you can do things like here, we're going to do a print schema, so it's going to kind of know all about this data set, so we're just going to run that. And you can see that immediately it actually has an understanding of what that schema should look like. You can do things like ask it to give you a describe, which gives you a summary of the values for something like current price. So you can look at the count, the mean, the standard deviation, min and max values. And then you get like a count and a number of columns if you want. And we've done that for both tables, so you can get some idea of what's going on there. Now, if I want to then store that data in anything like SQL, I want to be able to create run Spark SQL. I want to create those data tables in the Hive metastore, which is part of the big data cluster. So I just run a couple of items there just to add them in. No problems there. And then I have my Spark SQL query, which you can just see is exactly the same looking code, just embedded in here. Now, if Spark is new to you, I would say it's still relatively new to me. I wouldn't be too intimidated by that. What I would say is that what Spark gives you, or the community is so voracious around Spark that actually most of the stuff, like the examples that are out there, is more than enough to get started on here. And you can see I've got exactly the same data come back again. So Spark giving you one performance experience, but I'm really using it for that exploration capability. But now what if I wanted to actually then go and punch that data up into the data pool? Well, I can do that with what we call the Spark to SQL connector. So I can just pass in a JDBC command to the node. I tell it what it is, and give the aggregation table an answer. I just run that, and now Spark is actually loading that data up into my data pool as an aggregated table. Okay, so now when I come back here, why is it aborted? Come on. I can't see. I can't open the database. All right, I have to leave it for interest of time. But the Spark SQL connector can be used to load that data up, and then you can just query it yourself. So big data clusters isn't just about the compute engines, it's also about being able to visualize data. So let's look at what you can do with something like Sandance. Sandance is, again, another piece of technology available from research. It's open. You can actually go and install this yourself and use this over any data set. But you can see here, if I just hide this a second, how we're using this against telemetry data. And you can see that that's obviously the US map. And we're using some census data here from the kind of Obama era. And here I can change things like the point size and things like that. I can put this data into a 3D visualization if I want to. And when I do that, I can then add a z-axis to that data and look at things like income. And I can now, if I want to, even spin that round, so I can even do that. If I want to, I can then do initial filtering on that data, so I could look at that and say give me where the income is less than 40,000 and medium home value is, for example, greater than 800,000. Use that. Now you can see that there's still difficult to maybe see that, so I can now isolate the points that are valid. Punch that back up here. Go back into 2D, it's easier to see it. And there I can now actually iterate over those data points, and I can actually see there was a chap that has actually come through and has an income of less than $40,000, but is somehow able to buy a house of more than $800,000. So I kind of want to have a chat with him and find out what he's doing. So that's Sandance, and that is our 9th demo. Spark can also be used for doing things like transformations of data, and actually it's one of the most powerful implementations that you can use Spark for. So what we're going to do here is just use Spark to read a data file of adult census data. Just reading this, again, it's just starting up the Spark session. And whilst it's doing that, we'll be able to then print the schema and just see the table. There you go, there's a session starting up. I can now read that table. I can see the schema using that describe. And you can see that this table has hyphens as column names, for example. So maybe I want to clean that up. Well, I can just do that with a simple column replace and a find and replace, and now they're all underscores. Once I've done that, I can do some data exploration using Spark and actually find some things interesting that are about that data, for example, and then look at like distinct values and look at how, like in income, there are income bands in the data set that we can then go and use. Well, if I have that information, maybe I want to pivot and add a column based on that data. Well, in Spark, I can just do that by moving the data into a new data frame and appending the logic with an expression that's very, very SQL-like to actually go and do that. And there you go. I now have a column in here with that information. But Spark isn't just about an ETL environment. I can use this to go and build ML models and do statistical analysis. And some of that can be just very helpful when profiling data. And you can see here that I have all of that information available. Okay? And then if I want to, I can then do additional analysis over that data. And so I can do counts, for example, over those bands and just do some additional querying. And then when I'm done, I can come into the end here and just take that adult census income data and persist that down as CSV or Parquet or whatever I want. And there's my data set, and it's available right there. And then I can then go back in here, for example. I have my Spark location. There's the output, and you can see I have two files. I can actually just create this one straight over here, go through that same wizard experience, profiling that metadata. There's the data types, and away we go. And I can create that table, and then I can just go ahead and query that in SQL if I want. The reason why we can have that and the way Spark emits, you'll see that we have some files here, so that's why I use the directory structure. Anything that's prefixed with an underscore, just like in regular Unix world, is an ignored file, so we can just ignore that part and just move on, and you can see that I have both a Parquet file and a CSV file there. So that's 10. Okay, for this next one, we're just actually going to do something with one of the management capabilities, which is Kibana. So here, if I go into Kibana, what I'm going to do here first, though, is I'm going to generate, against my instance, some login failures, right? I've just changed my password here. You'll be able to see that once well, you can see the red text flying through the screen. But you can see that I've given it the wrong password, and I'm generating errors. But one of the things I said to you before is that big data clusters actually comes with all of this management capability out of the box. So what can I do? I can actually click on that Manage Experience, come here, go into my Kibana dashboard. It will just prompt me for my login. This is because I just I'm not running the right certificates. Come on. Sorry, I hit it. Thanks. There you go. There it is. I can log into that. And I can come in here and I start exploring all of the log data that we've collected across the BDC. And you can see we're getting, there's a ton of information here, but I've got a previously saved query, so I'm going to go and open that. I can look at login errors, for example, and here are all the login error messages that we've parsed and collected out of all of the logs, and it's all there available for you. And you can even go in, start clicking into this and seeing exactly, that's why there's a randomization on the time. Yeah, so that's fine. So that give you an idea of exactly what you can do here with the Kibana dashboard to build out your own experience. And you can also use our metrics dashboard, which is the Grafana piece, which I was showing you earlier. And there's all of the SQL Server metrics across all of the instances that is available to you. I'm just looking at one of the compute nodes right now, but I could equally just look over here and see that here is the master instance, and that's the CPU utilization. I can see all of the weight stats coming over here, and all of that is provided for you out of the box. You haven't had to do anything to configure that. So, and that's across the entirety of the big data cluster. So that is the management experience. No. Now, if I wanted to do something like ML algorithms and I wanted to install one of those into the BDC, I can simply do that using the demo 12. And in this one, what we're going to do is we're actually just going to create a simple application. Here, I've got a path to it. We're going to create this spec, this application spec. We're going to install a model actually in the big data cluster itself. And then once we actually have that in there, we are able to then do sentiment analysis over data in the data set. That's what happens when you have all of these screens. Okay. So I'm just going to, the Zoom is really messing me about. So okay, it seems there's a slight issue. So I'm going to have to abandon that one, I'm afraid. So the last thing I wanted to show you was something that is very kind of unique to big data clusters right now, and that is the availability groups. So in the master, we're running 3 nodes of SQL, and when you create a database, I want you to see this. So down here in the availability groups, you can see that is our environment, right? If I now connected to this database over here, launch a query, create database, and I put in here pass2, run that. It will take a little longer than a normal create database command because we are actually integrating it directly into the availability group itself. So now when I come down here, hit refresh, there it is. It's already inside the availability group. So that's pretty sweet. So we'll call that one BDC Wendy 12. Okay? So I think that is it for time. So what I'm going to do quickly is go back to our little stream sets demo and see if we've had any update on who had the preferred instance. So we'll go quickly into stream sets. Open our topology. Start the jobs, and that basically is now flowing the data from SQL into that table that we had. We just come over here quickly. And so is Marcus still here? Oh. So. Let's see if we've got anyone in here. He's coming up. That's data quality one. No. There's no one in there. Okay. Do we not have a BDC Wendy in here? No, there's no, it hasn't picked it up. The Twitter API is failing me. So what we'll do, it's still running through for some reason. It's not quite picked up all of the data. I haven't got it through. I try to get it to come through from there. If not, I'll have a show of hands for which was your favorite of the demos. Was it, let's go for 1, quick hand, 2, 3, I got first one, 4, 5, 6, 7, 8, 9, I wouldn't bother with the others. 12, yay! There we go. So I'm going to let Anthony pick someone who stuck their hand up for 12, and they can get the Windows gift card. There you go. Thank you very much. Well done.